Hello, my name is Mike Allison. I'm a senior director for Samsung. I'm also on the NVMe board of directors, and I'm here today to talk about SSD virtualization and what NVMe Express is doing to support that. Specifically, I'm here to talk about TP4193 PCIe exported NVM subsystem migration. This capability is used in the ecosystem to support things like confidential computing, where they use virtualized environments and they need to be able to migrate those virtualization environments to do load balancing, deal with hardware maintenance, and also supporting software updates. The current NVMe Express base specification supports exported NVM subsystems for NVMe over fabrics. And what we're adding now is the ability to support PCIe transport such that SSDs could support this new functionality. As part of that, we're going to be adding an exported controller. And as you can see, when we do this, by adding exported entities, the host is able to see only those exported entities and will not be able to see the underlying hardware or the controllers or namespaces that are behind those exported entities. What's also part of this capability is for the host to be able to specify the identifiers for those exported identities. So when they're migrated, those same numbers for those identities can be applied from the source to the destination during the migration. This capability is also allowing a host to apply a template to an exported NVM subsystem. The template enables defining supported capabilities that are static and configurable at runtime, such that the host can determine what they want to support. Also included is part of the template is the definition of what is the migration data and the format, and I will explain it as I go further along in this presentation. So to do all of that, let's just go ahead and show an example of a migration. On the left-hand side, I have a source server that is going to migrate a VM over to a destination server. So if we look on the left, I have host 1, which could be a VM, and it is connected to an exported controller that exists in an exported NVM subsystem. That host 1, that VM, can only see that exported controller and that exported namespace. It cannot see any other exported controllers anywhere else in the system or underlying controllers or any other controllers and namespaces. On the right, we also have the destination, and in there, there's already an existing exported controller that's already operational in there, and we're going to go ahead and build a new exported NVM subsystem in there for this migration. One of the things that's important for this presentation is if you look at the underlying controller and the underlying namespaces in both the source and destination, they are the same. And that is done on purpose to show the reason why we need to allow the host to set the identifier values for the exported entities. So to do the migration, the host first has to go over to the destination and create an exported NVM subsystem. From there, he can look at the existing exported namespace identifiers and then determine how they want to go ahead and build those in the destination. So the host would also look at the underlying namespace and then create an underlying namespace in the destination. For underlying namespaces today, the host cannot indicate what identifiers. It is the controllers that identify the identifiers for the underlying namespace. But with this new capability, the host can then say, go create an exported namespace and associate it to the underlying namespace and provide the same identifier as the source exported namespace. In the same way, you can do the same thing with the controllers. You can look at the exported controller identifiers, the underlying controllers, pick any underlying controllers in the destination, and then do the association to an exported controller using the identifier from the original source exported controller. So from this point of now, when you look at the source and destination, the exported controllers and the exported namespaces all have the same identifiers, even though the underlying hardware, the underlying controller, and the underlying namespace have different identifiers between the source and destination. Now we have to set up the configuration. This would be setting up that template that I talked about that defines what is supported by the exported subsystem. They would have to go in the destination and set up the same configuration in the destination. And now we have matching exported NVM subsystems in the source and in the destination. And now we're ready to migrate. So to migrate, you get to the point where you're ready to migrate, you can ask on the source side to collect the migration data. This is the runtime state of the exported NVM subsystem, which would include data that's associated with the exported subsystem, with the exported controller, with the exported namespaces. And then the administrating host can read that data, transfer that data over to the destination server, and that destination server can then transfer it into the destination exported subsystem, at which point now both the exported subsystem in the source and the exported subsystem in the destination are the same. The final step is to actually migrate the VM itself, so host 1 can then be migrated. And so now we can start running that host 1 on the destination from where it was migrated from and continue processing. But the process is not complete because now in the source, we still have the state of the original system, exported NVM subsystem in the source. And so there's operations to delete it and return it. And then you want to get rid of the actual underlying namespace. And at this point is where we're now migrated. So this shows the technology used to show how we export the actual NVMe subsystem data from one server to another to support this capability. On behalf of NVM Express and the NVM Express Board of Directors, thank you for attending this presentation. If you are interested in this kind of technology, we invite you to come and join NVMe and become a member and help us advance this technology going forward in the future.